Okay, having a look at this fab deck. DX milk tank. Customers reported it's tripped the power out. It's a bit vague whether it's the RCD or, you know, like an earth leakage fault, or whether it's just the current trip for the. I doubt it'd be the current trip because this is run off a control panel that also feeds to 2 compressors. So I think the tank is fused down from that, but that's going to have some big 30 amp 3-phase supply going into it, so it's probably not that, so it's probably the RCD. Anyway, on these, I was a bit surprised to get here and find it's washed okay this morning. Anyway, on these you can fizz off, hit the test mode, and you can scroll through. So we've got compressor, and if you hit the pause button, you can toggle between energising that output and not. So if I energise it, you hear the click and the solenoid open. So that's compressor 1, compressor 2, cold valve. That's putting water in. You can see the bubbles going in. I can hear a little pump running off in the distance. That's hot. That should be hot going in. I can hear that pump whirring. That's getting warm, so that's hot going in. That's I've turned that off, wrong button. That should be the acid pump, which it is. That should be the alkaline pump, which it is. And that's the paddle going round. I can hear the agitator. And then the pump should run. It does. That was a new pump a little while ago. And then the dump valve should open, which it does. And then the hypo pump should run. It's got a hypochlorite final rinse. And then finally the agitator runs in the anti-clockwise direction, runs the opposite way to what it did earlier. You can run them in 2 directions. So all the outputs are fine at the moment. So the only thing we can do, we can turn the power off here. I'd be careful with these switches. I've had 3 of them, I think, now fail when you turn them on and off. I think they're obsolete now. I managed to get some from, is it Radwell? Someone like that. They sell obsolete kit. I got 2 or 3 of them, imported them from the States. I mean, you could fit something else in there, but it's going to be a pain in the arse, because you're going to need to find a switch with the right configuration. And then you're going to need an extendable shaft and a new bit here and a bezel and everything. So anyway, just be mindful of these switches. So I think that should isolate the power. Check it, because some of these have 2 separate lives coming in. So we can Megger everything, because the favourite thing to go is the dump valve. If it's an earth fault, they used to be quite common, although they've got better. It's usually nowadays it's the diaphragm goes. I think they've banned a chemical they used to put in the rubber diaphragms to make them more pliable, flexible, and now that they just rot basically. So that's a favourite. That pump could be that pump. And then we've got hot and cold solenoid valves that I have had them short out, but they're rare. They usually, if they go, they just go. They burn out rather than short to ground. That pump's new, so I mean, I'd hope it wouldn't be that, because that's still under warranty. Although looking at that, it's getting quite a crust on there already. Anyway, let's pop the cover off and get the Megger fired up. Okay, you want a drum or something to sit this on, because there's a lot of weight and it just dangles off of these cables, wires. They're all the same colour, so the last thing you want to do is pull them out and not know where they go. Okay. So, looks like it's got wet in the past, but it looks dry now. Down the bottom there. Ooh, burning. We've got some burning wires. Haha, that might be it. That might be it, and that is on a, I think that's on a neutral. I'll get a torch. No, that looks to be historic. I was thinking there's a where that black wire comes at the top. There's a number on it, and I thought the number was like a bit of ash from where it had been burning, but it's just a number. So that centre one's burnt out. I think it's a very small type of DIN rail connector. I'm not sure. So I mean, if that melted, it could have melted through to the backing plate.
but I think without a jumper in there across the, you know, it's got that jumper in the top, that loop, that centre burnt one is probably not connected to anything, so false alarm there. I think that contact is just floating about. That is a, I don't think that's my work, because that's a molar contactor which I probably wouldn't buy unless, so I don't think I'm guilty of that. Not guilty. That's probably just running the agitators. So you think blue would be neutral, but it may not well. Oh no, it does go into the coil connector, so it probably is the neutral. It does look a bit suspect down there, because I mean, I can't think of it happening recently, but you could get a water leak on one of these hoses. But I mean, if it had done, the box would be wet. Anyway, enough whittering, let's get the Megger going. Right, there's a little spider running with my hand. One of them little red mites. I think it looks like I've squashed one there because there's a red stripe. So I've caught red mites from somewhere by the look of things. Anyway, well, that's a thought. If there's bugs in there, they could be shorting it out. The power comes in on the switch on the bottom, which is unconventional. Generally, we expect the power to come in on the top. Nothing on there. Let's press the test button. Let's confirm we've got a good earth, which we have. I've just put it on the ground wires on the motor housing. Okay, that's the incoming. Oh, that's one of the lives coming in. That's a short. That's the other live. And that, I think, is the neutral, which I'd expect to also be short. Why is that one shorted? Is that one shorted? That one, if we've got a good connection, is off the scale. And that one is the neutral, which you would expect to be shorted also, wouldn't you? Because obviously, something's shorted on the live, you'd expect to be shorted on the neutral. Okay. So, actually, I think we might have changed this switch in the past because the wires have got little pen marks on them, one little black dot and two little black dots. So I think I've done that. I've changed that switch. So that I didn't get the lives crossed over. We are getting a short on the one with one dot. The one dot live, which is this one here, which comes down to here. Ooh. Which is that one there with a rusty mark on it. Let's try that again. If we've moved it, we might have done something with my button. Okay, it's still showing a short. Okay, what we could do is split it here. Let's do that. Okay, just something to be careful of. That rusty mark there, that's enough to create a short to knock a trip out, because if that rusty line went inside, the current would travel through the rust if it was touching a piece of metal. So it doesn't even have to be anything major that will make something trip. Right, so we've broken that into two. So if I put the test lead on there, let's try it up here, it'll be easier. So we're now gigaohms, so that wire is good. Why is it? Oh no, I've just connected the wrong wire. No, I haven't. I've got confused. I thought this wire went to the switch and it doesn't. So this is the wire from the switch. That's fine. This one. Dead short. That goes up into here, so we need to pop the cover off that. Okay, we've got the cover off, and I think that's the only brown wire coming in, which is a bit odd because it's going to the circuit board. is it shorted to? That's our incoming power. I don't think any of these relays are stuck in. Unless there's something on the underside of the board. This is weird. This is a weird one. What should we do? Should we try the neutral? No, that's shorted too. Right. We might just be going up the neutral then. You might be going up the neutral through because that's probably going to go through the transformer. Because I suspect that's just across the live and neutral incoming. And we tried the neutral down here and we didn't have anything on it, did we? So let's pop this neutral out of here. Generally all the neutrals for everything are connected, unless you've got a double pole contactor or something, a relay, all the neutrals are connected together. So if you get one thing faulty, it will go back up the neutrals and it'll make everything that's connected to that thing look. There we go. So we've chased the fault into this box and then back out again because that should be shorted. Yeah, it's down the neutral. So we can pop that back in. We don't need to be in this box, I don't think. So what we need to do is trace that wire down here, and then we'll probably have to break all these neutrals up. That might be a pain in the ass. I might just go do something simple. It's easy to pop the wires off of these and test them first. And same with these pumps. We can pop the wires off, just pull them off and test them. So you don't always follow the logical things. You can follow the logic so far, and then decide to skip to something that's quicker, but not the next thing in the chain of testing, just because it's easier than trying to jab all these wires out of here. Yeah, anyway, might even end up being that burnt bit, we don't know. Okay, let's try that one. It's going to be okay because I can tell the bar's going up really high. Let's try the other one. Oh, that's different. That's 20 gigaohms. That's megaohms, and this one's gigaohms. And have we still got a short on that other wire? Yes. So we could pop the live off of there. Let's see if that goes into gigaohms as well, which it is going to, I think, 20 gigaohms. So we have probably got a pump somewhere piggybacked off of that live feed to that coil, because we've got an extra wire piggyback. That brown wire, that pump, yeah, that goes up to that pump up there. So that's probably the hot water coil. So that is that, and they've piggybacked the neutral off of there as well. Yes. So that's an idea. Okay. That's the live wire to that pump. Gigaohms, that's the neutral wire to that pump. So we think the pump is okay. That's that Wilo green pump, which is a booster pump for the hot water. Okay, so I think okay. Nothing wrong with that one. We're on the chemical pumps, gigaohms. We've just pulled the neutral connections off because the live wire should just go up to the
gigaohms. The live wire should just go up to one of the relays in that box, so the live wire should just go up to one of these and then off. So it's probably, unless one of the wires or these connections are shorted out, that disconnects that lot. So they're looking all good. Let's put them back on. Okay, so we've tested the hot valve, the cold valve, the hypo, acid and alkaline pumps. They're all looking good. So the other things we've got is the water pump, drain valve down there, and then there's 2 agitators on the top of the tank. Now the agitators run when it's cooling, so it's odd that the fault would only show up in washing. Anyway, so this is we think is the neutral for the pump. I haven't checked it, I'd have to trace the wires, but that was piggybacked into A2, which is a coil connection for that thing, and then that was dabbed in, the 2 were in together, so that was basically, they were getting a neutral to the pump by using that as a terminal. So what do we got here? This is looking gigaohms, we're off the scale again, so let's confirm we've still got a short. We have. Oh well, so it's not, doesn't look like it's the pump or the dump valve. Let's try that. This is the neutral on the bus bar. Megaohms. Ooh. And then what have we got on here? Right, I wonder what else could it be? Let's take this off. Let's go on here. Okay, that's our coil. That's our incoming live, 20 gigaohms. That's our outgoing live, 15 gigaohms. Is this shorted here? Now this test probe might not reach in enough to touch there, because you need a very fine probe to get the little holes. Hang on a minute. We might be chasing our arses here. We might be chasing our arses here, because that neutral there, some of these wires over the incoming cable is going to be one of these multi-core cables here, and they'll have a lot, well, I think we've got 2 lives, a neutral, a cooling signal for one compressor, a cooling signal for the second compressor, and a signal wire for the pump. So there might be a 7-core, or possibly one of these lives that's switched out might be feed to that other pump. I'm not 100% sure. I'd have to trace the wires, because there's a relay in there for the booster pump, I think. And what I'm looking at here is our incoming neutrals. That's our incoming wires here. I think they're the lives. These 2 are live. So they come in on these multi-core black wires. Well, the neutral also comes in on them, and then it goes off of that blue into there, which is this one here, but this is also dabbed in there as well. So we might be, the neutral, it should be switched, but because this isn't done right, I don't think, we might be just meggering all the way back to the main neutral on the incoming live supply, and that will always show an earth fault, because out on the transformer where the pole is, where the power comes in, they connect the neutral to the earth, so that the neutral is always the same potential as the ground you're working on.
If they didn't, the neutral could be floating. You could have 50 volts to earth on the neutral and then 300 volts to earth off the others, I suppose. So anyway, yeah. That might be a legacy of this burnout here. Somebody might have just done a few swapping overs and put things where they shouldn't be. So we might be chasing a fault that doesn't actually exist, because we might be just chasing the main neutral connection for the supply, which is really important. Why you need to isolate your neutrals when you're Megger testing. Let's get these two put back in here, and then we'll have a closer look at what's going on. Okay, I'm not sure how well we're going to manage this. We think that is an incoming live. Let's see if we can get this. That's an incoming live, and we think that is our neutral, which it is. You can see we've lit up 240 volts. That's one of our incoming black wires, which is joined to a ground, and that's the other one. That's 240 volts on there. So that's where we think those are. Now if I go onto this one, we're only getting 162 volts because we haven't got a proper neutral. 162 volts. We haven't got a proper neutral, but that is a proper. That's your proper incoming neutral. It's probably this wire here is a proper incoming neutral. Then we've got two lives. So that neutral wire that goes up to this box is off of the incoming. It's before the switch. So even though we've got the switch off, this isn't isolated. This wire may have been in here previously. And there was probably a little loop that went into there and a little loop that went into there and then into here, so we'd have had switch neutral, switch neutral, switch neutral, incoming neutral. Now somebody's put a switch neutral in the incoming neutral probably, this one here, because that's burnt out at the top. So really that blue wire wants to go. It's only actually supplying this box for the transformer and everything. There's no power on that wire, so it could go in anywhere. So we want to dab that in. We could join it into this wire. There's a bit of a mark on there. Yeah, let's get that sorted. Okay, so we've popped that neutral out of there, and then we're back on that brown wire where we had the short to start with. There we go, 11 gigaohms, so that's fine. So all we were doing was tracing going up that live, through the neutral, through the transformer, up the live into the transformer, down the neutral, and then into there, and then up that neutral on the black wire all the way out to the control box in the loft. And then from that control box down to wherever his breaker board is, and then from that breaker board out the way to the main poles where his earthing is, you know, where the earthing's done. That's what we were finding as a fault. So we need to sort that out. So this is on the right side of the switch, and then we'll Megger everything. So it might be a coincidence that it's done this when it's washed. It might be something else that comes on at that time. It could be a water heater. They're a favourite, especially if they took some hot out and then the elements kicked in. Okay, that's our neutral wire to the terminals. To there, that's our neutral that does the water pump and the drain valve, dump valve. That neutral does the coil for the contactor, and that neutral does the circuit board logic, just the transformer. There's no switch neutrals in there. It's just the lives that are switched. So anyway, what we're going to do, I think, is I won't video it because it'll be boring, is I'm just going to Megger test all the terminals that I can get to, just just to make sure there's nothing on the tank that looks earthy, but I think we were just chasing a fault that wasn't there because of this unconventional bit of somebody's done that without fully realising what the implications were of their bodging. When you turn this off, it should isolate the box. I mean, really, what they should have done was this incoming cable should go straight to that switch and not even bother going into that little mini DIN rail thing there. You don't really want, if the switch is off, you don't want anything but the switch terminals being live, ideally, if you're poking about in there. Anyway, yeah, so we'll do that. We've tested that pump up there, pushes the hot in. There's another pump I can hear whirring away when the cold comes in, because it's been capped off there, so they used to run the hot and cold in along there. They've brought this other hot one in. I think they've got a biomass boiler or something, so that's off of that, and they've just capped off the existing one. Well, that other pump may run kind of dead-headed when it's filling with hot water, and I can hear it whirring away in the background, so we need to work out which one of these wires is doing that and test that as well. Although probably that's going to be connected to the neutral in the control box up in the loft. So it's going to show a short, because even if it's not shorted, it's just going to go back to the incoming neutral again. So we'll probably have to get up in the box in the loft and turn the power off properly to that. Because even knocking the breaker off in the mains board isn't going to do anything, because all the breaker turns off generally. It's just your lives, unless it's an RCDO with it's like a little mini RCD and a breaker in one. It's not going to turn the neutral off. Which is why you want a proper 4-pole switch if you've got 3-phase stuff, or 2-pole if you're on single. You really need to be switching your neutrals as well, especially on farm stuff. Anyway, enough wittering. Okay, we've got a dead short on that grey wire. We'll have to trace where that goes. That may well be the booster pump. Couldn't get the thing in there, so I'm using a little wire as an extender. So that grey wire is faulty. So we've got the red, purple and yellow to test, and then that's pretty much it. Well, yeah, we've got something on that grey, so that may well be the booster pump, which may not be actually faulty. It might just be going up the neutral. Okay, so we've got a short showing on the grey, the red and the purple, which, now I think about it, is probably the booster pump, the cooling solenoid for one compressor and the cooling solenoid for the second compressor. So that they will also show, and there's a priority relay on this as well, so if it's running, the compressors are running an ice builder at the moment. If the tank calls for cooling, when the cooling signal goes out from here, it energises a relay to disconnect the cooling feed to the ice builder and switch over to the tank, so the compressors are not trying to run two things at once and doing neither of them well. So that relay would also have a connection to earth via the neutral connection. So that's probably what those 3 wires are, but we'll have a pop the cover off of this again and just visually check what colour wires go to the booster pump and the compressors. Okay, so the purple wire I think is, let's see, acid, alkaline, hot, cold, boost. That's the purple one, so it's the booster pump. Showing the short, they got the neutral. And then down the bottom here we've got Comp 1, Comp 2 and Economy 7 relay. Comp 1, showing the short. Comp 2, showing the short. Economy relay not used probably. Yeah. You could program the economy relay to bring on the water heater at night time on night rate electric, which is, it's a handy feature, but
It's a pain when the clocks change, and I find you're better off putting a mechanical clock in there because people can see what it's actually physically doing. So we're just testing all of these. It's about 250 mega ohms, which is nowhere near earthy enough. I mean, even at 1 mega ohm would probably run without knocking the trip out, but there would be something, if it would be something like if something was damp, which would dry out. If there wasn't dampness and something that's reading 1 mega ohms knackered, could have carbon tracking in there or something. Right, so we've tested everything on the tank basically. Is that a spare wire? Let's test that one. Place. Yeah, that's fine. Yep. So we'll confirm we've got a good earth on the chassis. Yeah. So it's looking like that signal we're now getting is the booster pump on the 2 compressor feeds, which is to be expected. So we need to go and check the booster pump. That's the only thing that would be on during the wash. The compressors wouldn't come on in the wash. If it was those, if it was one of the, say, the solenoid coils, the problem would be in cooling mode. Okay, we'll turn the switch back on. Let's go test mode, test, refrigeration. That's 1. Refrigeration 2. Refrigeration 2. Cold valve. See cold water coming in. I can hear a pump running in the distance. Where is that coming from? It's got to be in here somewhere. We need to follow them pipes. Find out where that pump is. That's the hot valve. So that other pump, you can hear the tone change because it's pumping against a shut tap. But this one's kicked in now. That's the hot coming in, acid's working, air supply's working, agitator's going round, dump valve, hypo pump, and then the other agitator direction, off. You don't want to run the acid and alkaline too long because the chemicals will mix in there and make chlorine gas or something, and it can also bugger up the stainless. We'll put this on to rinse when we've finished. So this all checks out. So the only thing we have to do is check the booster pump, I think. Okay, spoke to the customer and we've got a slightly different story to the one we had earlier. The trip that was tripping was this one here, which is this little thermal overload for the pump, which they've had to reset a few times now. This could be because we've put a new pump on here, which is probably slightly bigger than the original, because this is a 270 and the originals were 250s, I think. Although this might have had a 270 on because it's quite a big tank, but it might have been a 250. Plus these little trips get tired over the years, so it's probably just knackered. But we will check the pump and make sure the capacitor's good, and we will put the thing on to rinse and check the run current isn't excessive. But I think we're just going to end up bypassing that thing for now. In fact, I don't even think they sell that as a spare part anymore. They don't put them on the new ones. The older ones, they used to put the pumps were horizontal. So in the winter time, there was always water left in the pump because they wouldn't fully drain. So winter time, tanker man comes on, puts the wash on, wash water's frozen in the pump and it'd burn the motor out. So they used to put these little trips on there, used to protect them a bit. But the vertical ones are just fully draining, so they don't really overly need it on there. And these little trips, they've only got so many trips in them.
if they trip too many times, it wears them out. You know, they've got something like, I don't know, 30 trips or 50 trips in them in their lifetime. That's probably going to be a 20 plus year old thing anyway, so it's probably got a bit tired. Anyway, we're going to check the capacitor, make sure that's good, and then we'll test the run current. Okay, that's bang on 14 microfarads, and I was trying to think whether these are 14 or 16. I think they're 14s. I think they are, because we had one the other night and that was a 14. Yeah, I could just about see the 14 on the label. So yeah, that's in spec. So we'll put that wire back in, we'll put it onto rinse, and we'll check the run current. Okay, put it on rinse, it's doing a cold fill. That's rated about 3.9, 5 amps, 4 amps. Capacitor checks out okay. So we've just bypassed that thing. I think it was rated at 5 amps. See if they still list them as a spare part. Oh, we go, hypo. It's going to do a hypo rinse. Not a lot of flow in there, is there? Leak actually, it's leaking on that tube. It's running up and down, depends how much air bubbles are in there. So that hypo pump's not working too well, I think the tube's come loose. We'll have to check, that might be why this is all corroded. We'll have to check that connection there is there. Basically running about up to its maximum. Although, you know, you can move this about, it'll change slightly. So I don't think the problem is the pump. Okay, we've got this on to rinse again. We've cleaned that fitting out. The pipe was full of scale. So hopefully we'll have some, well, not scale, it's like crystals. You get like the alkaline chemicals, it goes like salt in the tube. So hopefully when that pump kicks in, if it kicks in, I would have thought it would have been going by now. There's my screwdriver, there it is. Sometimes when you have the pumps apart, they don't have enough oomph in them to actually turn, so it can pay to give them a bit of a turn with a screwdriver. I don't think it's on yet. No, we haven't got, the hypo's light isn't on. There we go. So there we go. It's sucking out from the barrel. Coming down the tube, that's better. That's a lot more flow than we had before. I might put another cable tie around that. It just makes me a bit nervous because that's under pump pressure. We haven't got any flow back, so it shouldn't do because the two rollers pinching that tube on should stop any flow. Yeah, they just appear to be full of scale crystals.